Carbon cycle is a process in which carbon is moved through the physical environment. This includes movement between the atmosphere and the ocean. There is a relationship between CO2 emitted into the atmosphere and that which is used by photosynthetic organisms in the environment. Some of these photosynthetic organisms on our planet live in the top few meters of the ocean and are responsible for 50% of the oxygen produced through the conversion of carbon dioxide to sugars. Carbon dioxide in the atmosphere diffuses into the ocean before it is used by photosynthetic organisms contained in the ocean's surface. However, not all CO2 gets used by these organisms. Some CO2 makes its way deeper into the ocean and remains in the deep ocean and sediment in the ocean floor. It is in these lower depths where it must sit for approximately 1,000 to 1 million years before being cycled back up into the atmosphere. This stability began to lose its balance at the start of the Industrial Revolution in the late 1700s, when CO2 created by the burning fossil fuels increases the CO2 entering the cycle. The CO2 levels in the atmosphere have increased roughly 40% since we started burning fossil fuels. This addition has put a strain on the producers which keep the carbon cycle in balance. The sinks for CO2 to enter are limited and have already begun to overflow. The increase in atmospheric carbon dioxide has led to more carbon dioxide diffusing into the ocean. When carbon dioxide is diffused into the ocean, it reacts with water molecules and produces carbonic acid. As more carbonic acid is present, it becomes dissociated into bicarbonate and hydrogen cations. As these hydrogen cations build up in the ocean, it decreases the pH of water, making it more acidic. As acid levels increase, fish are being found which have developed acidosis, a condition of decreased blood pH that can cause issues for their heart and other internal organs. This pH has also affected olfactory organs in fish, leading to disorientation and preventing fish from avoiding predators. The amount of carbonic acid has also led to increases of calcium carbonate in sediments instead of in the upper layer of the ocean. This limits the amount of calcium carbonate available to animals, which use calcium carbonate as a building block for their skeletons or shells. Because of this decrease in available calcium carbonate, the deformity of juvenile crustacean shells and skeleton formation in corals is becoming apparent. Off the coast of Alaska, a species of pteropod has rapidly decreased. This species of pteropod is 40% of the food source for pink salmon. A decrease in this organism, which is low on the food chain, will affect any animals higher on the food chain, like the pink salmon that live on pteropods. This can lead to a reduction in the amount of fish available as a food source for people and animals higher on the food chain. Has ocean acidification occurred in the past? According to ice core samples, global changes in pH have not been lower than 8 in roughly 50 million years. There was a slow increase for pH over this time for pH to achieve a life-sustaining level. However, pH is beginning to decrease at a rapid rate within the ocean. The last known occurrence of ocean acidification occurred roughly 55 million years ago during the beginning of the Eocene period. The increase in carbon dioxide levels of the Eocene period resemble the magnitude of atmospheric CO2 increase which has occurred in the last 50 years. The major difference is that during the Eocene, a 3,000 petagram increase of CO2 levels occurred over 6,000 years. We are currently on a course to increase atmospheric CO2 levels by 5,000 petagrams in roughly 500 years, a rate which is 20 times greater than what has been discovered based on fossil records and ice core samples of the Eocene period. This increase may make it difficult for our planet, mainly the ocean, to adjust.